Hello, everyone, and thank you for joining us. My name is Sam Van Ryder. I'm a Strategic Accounts Director here at Dragos. And welcome to our webinar. We're going to be talking about navigating NERC CIP 015-1, otherwise known as INSM. So these are strategies for internal network security monitoring at scale. We have an impressive panel today, including speakers from two of our valuable OEM partners. In just a minute, you're going to hear from Tim Watkins, SEL's Senior Engineer of Global Accounts. We have Nick Janisevich, who is the Emerson Cybersecurity Business Development Manager, and our very own Phil Tonkin, who is our CTO at Dragos for the energy vertical. But before we get started, let's just a few housekeeping items. The session is being recorded, and the recording will be emailed to everyone within 1 or 2 business days after we're done. Also, your microphone will have been muted to keep the noise levels down, but we want to interact with you. So please do use the Q&A chat feature to submit any questions you have, and we'll work to get to your questions at the end of the session. And without further ado, let's get our experts up here, and I will kick off this panel discussion. Let's start with you, Phil. Let's start with some fundamentals. So can you help our audience understand NERC CIP-015-1, also known as INSM, Internal Network Security Monitoring, and what's the technical rationale behind it?
So the technical rationale behind the CIP-15 regulations is really codifying into the standards the requirement to do east-west monitoring within critical networks in the bulk electricity system. We've got I've had for some time people doing this because they recognize a particular risk in this space and wanting to do it to manage that. But we hadn't yet seen a firm requirement on utilities that are operating medium and high assets within the bulk electricity system to actually do this in a particular way. And it goes beyond just requiring a particular type of technology. It's also about making sure that it's implemented the right way, making sure that the evidence of what it's doing is appropriately captured. So there's a whole raft of detailed requirements, and it's something we've become used to within the NERC CIP regulations. It's not just you should be doing something, it's telling people in a very prescriptive way what they should be doing, where they should be doing it. And that really helps organizations to understand the scope of where they should be implementing these types of technologies.
So why is network security monitoring so vital? And I guess, Tim, maybe we'll start with you here on this. And can you give us your view, Schweitzer's view on why this is?
I think one of our biggest advantages over anyone wanting to cause a cyber effect on an OT system is knowing who or what is talking to what and when. I said these systems are proactively engineered. They take years to build the spec and design and get that system operating. And I look at it as that the majority of the attacks are not going against embedded firmware on a PLC or a relay. The bad guys just living off the land using allowed actions. So network monitoring of human to machine traffic, either by the day of the week or the time of the day, becomes very important. As an engineer or technician, I don't work on weekends unless there's a problem. During normal operations, there should be no unplanned events or engineering change orders being conducted. On the machine-to-machine side, the ability to monitor function codes of automation packets when they change from 6 months of read-only action and all of a sudden the right action, that should be instantly alerted upon or noticed or at least viewed from both the operations center as well as the security operations center. If right action or right mode is on, why? So another kind of part about this is that every manufacturer has security features in their systems that can be implemented. SEL's version of a PLC data aggregator Comproc is a real-time automation controller or an RTAC. It has a plethora of cybersecurity or security features that can be implemented to increase the value in that network monitoring by increasing visibility of events happening to both the Ethernet or serial connected relays. So network monitoring is not just for stopping adversaries. I also kind of looking at the kind of like the operations side. The third leading cause of power outages is misoperations in control systems that are initiated by a non-malicious human error. So network monitoring has kind of a goal in there. And so I kind of like make a challenge to make a goal to sync prescriptive human actions from the engineering change order process and monitor that with detection. Detection would be able to ensure that Tim was at the correct substation using an authorized device and a protocol to connect to the correct relay at the right time. If I'm at the wrong substation, if I'm using an unsanctioned laptop, if I'm attempting to update the settings file on the wrong relay, detection could be used to prevent or discover something that could lead to future misoperation.
So really good views there, especially going beyond the threat perspective. So, but there's still parts of it, right? So,
Mhm.
Nick, what do you think? You have any thoughts on that?
Yeah, I would second exactly what Tim said there and expand on it, that, there's a lot more to it. A lot of these devices are very dated and old and that are difficult to protect in a lot of cases because as he said, they're years in the making. And there's a lot of life cycle considerations with these devices. And the network security monitoring provides the best protection that you can when you lose the ability to track and keep these devices updated. And knowing what's out there is essential to being able to protect it, because if you don't know it exists, you don't know it's there, you can't protect anything. And I think we lose track of what's out there and what we have. And these types of services and types of programs allow us to better track that and understand what's going on from a day-to-day basis.
These are really good points that we typically don't think through when we're talking about NERC-CIP, because NERC-CIP is usually framed around threats, right? So the operational value is super important. So appreciate those responses. But Phil, can you maybe bring us into the cyber value?
Yeah, no, absolutely. And when we consider all of the SIP requirements that have come in the past, they've never just been invented. They've started from a real solid grounding of an understanding of the threat at any time. And unlike in any other sector of the any other part of the electric sector in the world where there are looser regulations, NERC-CIP has absolutely driven a level of cyber hygiene in the OT space, in particular for the bulk electricity system. You will find in all the parts of the world where it's been much more discretionary, and organizations have done it because they wanted to mitigate the threats. The original controls were all about hygiene. They're about putting in place good perimeters, making sure passwords are being maintained and monitored, knowing who's coming in and out of the environment physically. And they've evolved over time. We saw CIP-13 come along because people were starting to get concerned about security of the supply chain. We saw CIP-14 because there were greater physical threats. With CIP-15 is very much driven by a real threat. And it's like Tim said, we're seeing threat actors now living off the land. They're operating within those hygiene controls and coming through into these environments. And we know because we're tracking those adversaries. We're seeing them in the IT environments and trying to use that persistence there to get into the OT environments of everything from mid-sized utilities through to the larger ones. They're looking to utilize those connections that go from IT into OT for true operational reasons. They need to exist. If we had a true air gap, we wouldn't have firewalls. You just wouldn't have connectivity between those environments. It's necessary for us to manage a robust and reliable and ever greener energy grid to have that kind of connectivity. And so for that reason, we have to have those connections. We have to be able to use them. And this is about being able to monitor what's going on within those, because there are real life threats around that. And when you understand the behaviors of those adversaries and you know what they're trying to do, you can then codify those into detections, but also generate the right mitigations around them. And I think that's a really important build on understanding the assets that are out there in the environment. Once you know what they are and you know what your legacy assets are and you can see what vulnerabilities they're exposed to, you can make a real world decision on what the right risk-based approach is to managing those. Yes, some of them are very old. Many of them may not be patched. Do they really need to be? And quite often we can take an approach of deciding we don't need to do it because they're old and it's hard. having good visibility of the assets, knowing what the vulnerabilities are, knowing how those vulnerabilities can be exploited, knowing which threat actors target those particular vulnerabilities and whether they're even interested in your industry can help you to take a prioritized view and make a conscious decision not to do something. And once you've done that, we can really drive it down to maybe only 3 to 5% of them really actually need any work to be done on them anywhere. And many of those will be on the perimeter, and organizations have been doing a good job of maintaining those anywhere. The CIP-007 standard, defines the need to do vulnerability management, and so it's the utilities have always had a good approach around this. This helps them understand what are the things further down within the network that may be at risk, and understand how anomalous behaviors around the natural features of those devices as well can be targeted. Because when you send a circuit breaker open command via DMP3, it's not exploiting a vulnerability in the device that can be patched. It's exploiting the native vulnerability in the protocol itself. And so once you get this kind of network monitoring in place, you can start to see how might people be living off those capabilities, beyond the vulnerability, beyond the code errors or the patches that need to be applied, but instead thinking about how are the adversaries using the way the environment is built in order to protect it.
So, Tim, what are some of the foundational challenges that utilities are going to face when they're implementing INSM in their environments?
And I can think of a couple of them come to mind really, really quick. I think one is I'll start with the utilities' current monitoring posture. I think that previously OT owners and utilities only wanted to monitor the northbound, southbound traffic from, say, the firewall between corporate to the ops center, or from, say, the ops center into the substations. I look at this as only half the story, and we need to focus more on that east-west communication between the human to machine and as well as the machine to machine devices. Uh, we can't always trust physical security. I know that we put a lot into the idea that physical security, nobody will ever break into the substation, nobody will ever arrive there, but we can't trust the mindset of a disgruntled employee or an insider threat. We've got to be able to do things to prevent them from being the bad person. Another problem is the age of the network infrastructure and systems designed to last 15 to 20 years when the switches were designed to last 5 to 12. So in many locations, I've seen older traditional or unmanaged switches being used, and these switches were around before span ports or many of the security features that today's switches can provide. And it becomes difficult to capture the packets and get them to the Dragos sensor. So adding physical taps is an option, but it will only get trunk traffic between switches or the traffic between that last switch and the firewall. And I also look at taps as another added physical layer point of failure into the system that are already sometimes very difficult to discover physical layer problems. And all of the above translates into hardware cost of adding more sensors or complexity of getting the packets to those sensors. I also look at the complexity problem in encrypted traffic. Everybody thinks that encryption is the savior and the key, where I don't think it's always no encryption is going to last that life of that control system. We replace our cell phones and our laptops out every 3 to 5 years and get the next latest, greatest TLS. In these systems, we don't have that option. So, and then also, I've seen plenty of cases where the adversaries living off the land, they use the TLS or the SSH center to hide themselves in plain sight away from the network monitoring solutions, which makes it more difficult for Dragos to be able to do their job. So that's something to contend with the direction that we're going, where to encrypt, what to encrypt. And I'll end it with utilities are still highly reliant on serial traffic. So serial is great from the point-to-point perspective. However, just like encryption, it does give an adversary or an insider threat a place to hide in from detection.
So then coming back, and maybe we'll take a step back, Phil, for you, the next question. So what is the difference, though, between what companies are doing today versus what INSM and whether that's a spirit of INSM and the guidelines.
Yeah, the big difference is that focused on the east-west traffic. It's looking at what's happening within the networks beyond the perimeter. So since CIP-5, there's been a requirement for organizations to have an IDS or an IPS on their perimeter, and many of them have relied on the basic capabilities that exist within their firewalls. And sure, many of them will look at how that can help them meet some of the needs of INSM as well, but they don't have the visibility into those lands, and that's the big one of the big challenge really when it comes to thinking about how this is going to scale. When you've got these these large networks, with often quite a lot of real-time communication, some of it not even routable, people are gonna have to take a look at those switches, because that's how the traffic is moving from east to west within these spaces. It's not going zone to zone and traversing through firewalls. In the substation space in particular, a lot of the communications are not routable. They're going from switch to switch and device to device. And so making the changes to get that full east-west visibility, or at least to for organizations to take a really close look at where the risks may manifest and take a more reserved approach at where they're monitoring, it's going to require some investment in those networks. And these networks are also much more distributed than where the controls have been in the past. A lot of the regulations in the past have focused on those externally routable devices themselves. And in the substation, that's the stuff on the edge. It's highly likely that the scope of INSM will be slightly greater than that. There's still some work to do to fully understand exactly, when you go into the substation, what the scope of the regulations is, but also the scope of what you could monitor when you get there. And I would urge that people read carefully the requirements of what they should do, but also think about where threats may occur as well. It may be in the other networks that are on site. You can achieve greater value and around asset management, threat management, by going beyond compliance in this space, and taking a look at, whilst doing that engineering, what other value can you get? So you start to figure out how you're going to take the traffic from those lands, how you're going to feed it into sensors, how you're going to collect that information and bring it back. It's going to take a lot of work. When thinking about how to do it, there are financial mechanisms that are out there, and since FERC put out the order, asking people to think about INSM, recovery mechanisms were put in place, to allow for rebate on those investments, as it becomes a compliance requirement. Once the initial embedding period expires, that we'll expect to see organizations building this into their rate cases. But that investment needs to go beyond the software. It has to be thinking about the engineering effort that's required to go into multiple locations and make the capital investment in new switch technology and the hardware required to put the sensors in place and monitor this. So it's gonna take a big collaborative effort across supply chains. Whether you're looking at a DCS system in a power station or a protection system in a substation, it's going to require a lot of collaboration between parties like Emerson, Schweitzer Engineering Labs, and ourselves to help to deliver that kind of monitoring.
This begs the question. This is not going to be a quick turnaround for any of this, right? And it's going to take time. It's going to take time. We often talk about a journey. So Nick, maybe you can start off. Like, where should organizations start?
Yeah, so when I was listening to Tim and Phil talk, I started thinking about, some of our integrations that we've done in the past and using those as kind of examples. On the generation side, a lot of these facilities are very large facilities, and they're geographically spread out in a lot of cases too. And some of those geographically separated areas are really key areas that you might want to have some monitoring on, right? And it's not just the infrastructure of the switch itself that's a concern, but the architecture, the layout, the cabling. Do you have the extra networking cable or fiber cables that you're going to need for this? So really starting to think about the whole picture of your plant or your facility, the age of those devices. Do I have enough extra, networking cable runs? Do I have fiber runs? getting that network drawing, getting it updated, knowing what those connections are and the distances that you're going to need to bridge. Those are going to be things that you're going to want to start inventorying and looking at. And then to go along with that, you're not just going to have those issues, but you're going to have the plans for the work to be done. If there's work to be done, you're going to have power considerations. Do you have room in the cabinets to put these extra sensors in and things? Those are things that aren't going to be resolved necessarily overnight if you find that you don't have room or you don't have the power capability to support these new devices. So getting that on the roadmap, because as you said, there may be capital budget things that have to be considered to get these work orders in, and then in some regulated environments, it might have to be done during an outage, and this is going to be a long-term planning thing that's going to take place to accomplish this. So start that inventory, as soon as possible to plan that.
So and maybe Phil, you can take this next one. What initial steps should utilities prioritize for when they're working towards INSM implementation, and how do they align those with the specific NERC-CIP requirements?
The first thing I would recommend anybody do is build a cross-functional team. You're in particular when you start thinking about monitoring in something like a substation or a power station environment, it's got to be a team effort between the engineers who understand and know those operations and have often got incredibly high standards, which is how they've maintained the reliability of the grid to this well to this date. It's the standards that are there are designed to make sure that change is done in a very controlled way. And whether it's looking at what does an outage look like, what are the drawing standards that need to be followed, what are the health and safety requirements to run those extra fibers to put another cabinet in place. They're complex tasks, and you need to do it with the right advocacy and the right skills from across a business. And any attempt to do it without those things will ultimately lead to significant delays. And whilst it's going to be 3 years to get before this becomes enforceable in the control center environment, 5 in the medium facilities like big generation plants and the transmission substations, those things are going to are still going to take quite a lot of that time to get done and achieve compliance across all of those spaces. So it's building that team, but doing it quickly. Getting that in place now, starting to think about addressing what those challenges might be by starting early. If it's 5 years out, to get all of the substations done, you need to be doing your first ones right away. I've had the luxury of deploying into substations in the past in my previous life as an asset owner and operator, and it can be a real collection of tasks that need to be done. There's some you never know exactly what you're going to find when you get out in some of these sites. There's an idea that these things aren't documented. You hear a lot in OT that there are no network diagrams and nobody knows what the assets are. I guarantee the engineers know exactly what the assets are, and just because there's not a recognizable network diagram doesn't mean that there's not an engineer out there that knows what that network looks like. The drawing's in CAD, I guarantee it. And it'll have been stamped by a PE, a professional engineer that is, has been certified by the state to carry out this work. People say there's no change control in OT. Try changing a setting on a relay and in a bulk electric system substation. There are standards that have to be followed, and people know a lot of these things. But it's about how you decipher those and build that right information, because it's hard to build a new network by reverse engineering CAD drawings. Because in the past it just was a thing plugged into a switch, and I had the pleasure of working with Tim on deploying the OTSDN in substations and doing it really, really well, by building out an understanding of exactly what the assets are doing, how they're supposed to communicate, so you can create a really locked down network. It's a big task, because you've got to gather a lot of information up front to make sure that you don't create any operational impact in that sense. So it's building an understanding of the scope, understanding what's going on in the sites, trialing it, get out there, pick 10 sites of different, different equipment and different locations, different engineers, and use that to develop the rest of the program. Try and help to understand what the efforts are going to be, exactly how much it's going to cost. All of these things in terms of the engineering planning require you to have a good understanding of what's actually out there. And I think that's always got to be the best starting point. Build that team, get out there, try it, and then build out the rest of the program.
So this is a good segue into my next question, which is really towards all of you, and maybe Tim, you can start. But we have Dragos, Schweitzer Engineering Labs, and Emerson all on this webcast. Very smart guys, all of you, and excited to be part of that partnership. Maybe can you share how we're working on joint customers and how the collaboration is helping these utilities tackle the INSM issue?
Perfect. Yeah, Philip already kind of started on the conversation with this with the software defined networking. That was an SEL developed solution trying to create a better Ethernet specifically built for OT environments. And I think combining Dragos and SEL OT SDN, we've been doing this now in greenfield and brownfield solutions since about 2017 when the product was first released. But that's a journey. And Phil was really hitting some of those parts because as utilities and other industries begin using Dragos and OTST together, there's going to be a lot of lessons learned. The combination that Phil had with different O&Ms that are going to be installing this, they needing to learn it, understanding it. It really comes out with initial training and demonstration systems, and these demo systems kind of grow into pilots. The pilots become organization standards or specifications. And then these demos and pilots are important to understand the technology, and it's also important to win over the engineers. You've got to and make them understand why this is important and what it's being used for. But I believe that network monitoring can help them reduce time in solving an operational problem. If they have that granularity and detail that they could prove that Tim was at the wrong substation and changed the settings file, that was the cause. That's easy to fix. That's more training for me and changing the settings file on one relay back to what it should be, vice not trusting the entire substation and having to go through weeks of arduous labor to make sure that everything's correct. And then they also have to understand that this equipment isn't going to increase their complexity or their operational risk itself. So that's where those pilots, as soon as they get comfortable with it and you have their buy-in, things are going to continue to increase moving as a team effort rather than thou shalt do this because it's NERC CIP-015-1. So I think we have several large utility examples that we already have moving forward. They're well past the pilot and stage, and they're moving into specifications for these organizations. And this gives the engineers, technicians, and auditors a rock solid understanding of all the allowed devices within the system. They know every protocol that's being communicated. And not only do you get that identify and detect, which can reduce your time in a response and recovery, but you're also prescriptively building protect in as well. So combining detection with OTSDN, it reduces the upfront cost of hardware sensors, and adding detection increases that our detection really kind of decreases the total cost of ownership of that control system and reduces the O&M funding over time.
Nick, what's your take? How are we helping as a partnership with our customers on INSM?
So one of the things with the partnership that I think is really key is, the knowledge sharing from both sides, right? Like, Dragos, for example, I know you maintain an Ovation lab, and that's really critical for our customers. Not only are you familiar with Ovation and can understand what's going on from a Emerson product standpoint, but then we also take it on our side from a development standpoint to take a look at what you're doing and make sure that it works well with our system. And having that deep collaboration really provides that assurance that we're going to maintain our system in a way that's reliable, even while introducing a new vendor and new product into the mix. So having that collaboration all the way at the very beginning and that comfort level with both of us on each product really gives that assurance to our customer that, they're getting a good service, they're getting a valuable product that is going to meet their protection requirements going into, these new regulations, because they won't, in a lot of cases, they won't look at things unless it's something that, Emerson says we're comfortable with putting on our control system. And I think that is really where a lot of the value comes in the partnership. And then it goes even beyond that. Like, I kind of hinted at it at the beginning with, Ovation. If you don't know Ovation, you don't know what's right, what's wrong, what should be there, what shouldn't be. And that can be even more detailed than just baseline, right? Because you could baseline things, but not everything's always going to be caught, or you might not interpret things from a baseline necessarily the correct way without going to the original, DCS vendor and saying, hey, what is this? Is this what we should expect? Is this what we should see? So with that collaboration, we're able to do that and keep on top of it as things change, right? Our product's not static, your product's not static. So it's a continuous cycle and it's a feedback loop that we have to keep going. And then as we integrate with customers, each system is unique and that feedback loop has to continue because we learn new things as we integrate with our customers that we might not have noticed under other circumstances. And we have to keep that development and that feedback loop going.
Phil, any final thoughts on this question here?
Yeah, I mean that really is a great point on the customer having the confidence that making these changes is safe. I think it's probably one of the most common issues that I find whenever it comes to deploying a monitoring technology is that the trust is absolutely there with the technology vendors today. They trust Emerson and that you've built a system and it works. If people trust SEL, the longevity of the relationships that you have already got between utilities and organizations like SEL and Emerson exists because of a long earned trust in the products and in terms of their reliability. And so when a new thing comes along, in particular cybersecurity, which is not ever seen as a certainty like other risks in the engineering environment, cyber is something that requires somebody to have an intent and a breakdown of all the controls to really get down into the OT space. It's hard for an engineer to see that risk as being a priority over some of the other things that they're dealing with. Reliability is their number one concern. And so knowing and hearing from the OEMs, that hey, this is a good idea and that this is safe because it's been tested. We've been through it in the labs. We've developed specific content specifically around these systems, and we know that it's not just generic. We're not just looking for for some signatures of some threats that you can just download off the internet. This is carefully created content and detection ability that understands the environment, understands the context of an innovation system or an RTAC, and the communications it's going to send down to an IED. Those things help us to provide that context to the user about not only what the device is, but what malicious threats might be happening, so that people could actually take really tangible responses to what they're doing and know that doing it is safe. That's the primary thing here is that we mustn't ever look to deploy cybersecurity where it makes things less safe. It's not a one or the other. There's no compromise there. Safety first in the operational technology environment, and so adding cybersecurity has to contribute to that safety journey. And I think that this is still the safest way to secure the environments. There are many different cybersecurity controls out there, but passively monitoring the network is absolutely the safest way to detect what these adversaries are doing and get in there and do something about them before they create an effect.
Lots of really good thoughts here over the past 30 minutes or so, and this comes really to the conclusion of the panel from a quick question from my perspective. Thank you all for each of you for being here and participating. Let's go through some of the Q&A. It's great to see the Q&A come in. So I'll go through these and we'll try to get as many as we can. If we can't get to them, we'll follow up separately as we get those in. So let me go through these real quick. So I have somebody saying, I'm not a member of the electric industry, but what happens in one industry country quickly can pivot to others. So trying to get a handle on it. Do you see similar standards to be required in other industries? Nick, do you want to try to take that one?
Yeah, so from an Emerson standpoint, and I think this is probably true for SEL as well, we protect other industries or work in other industries, water being, a big one as well. And if you look at the recent big news items from these, threat actors, a lot of them have been in the water wastewater industry. And, the EPA and CISA has been making some very strong recommendations around, network security monitoring as well. And so I really do believe that this is a good protection. We're going to see it come to other regulations around the world, not just the United States, but also in other industries within the United States as well. I think it's absolutely, as was mentioned, one of the best and safest ways to protect a system, particularly when, as I mentioned earlier, there are older systems, older vulnerable systems that can't be patched or updated. This is an easy, safe way to protect it. And cost effective in a lot of cases. So I think that you're going to see a lot of other industries or regulators jump on this as something that is a highly recommended, if not required, activity.
Yeah, I just to sort of amplify on that point, NERC-CIP is probably one of the most prescriptive rule sets that are out there. It's very, very specific in its scope. There's no discretion over what is in scope or out of scope. It's very, very well defined, and that's one of its strengths, and it's one of the reasons it's one of the most impactful. However, across the world, there are broader sets of OT security requirements. You've got NIS directive in the UK, you've got NIS 2 in Europe, and now being transposed into European law in each member state. You've got the OTCC in Saudi Arabia. You've got legislation in Australia and other countries, and all of them make reference to this kind of monitoring technology. They are less specific about exactly where it needs to be applied and how it should be applied, but all of them are asking for it because there's a recognition that it is, without knowing what's going on within the environments, that you've got all those other protections around, you can't take the right responsive actions. Prevention is the panacea, but there's always going to be a time if you've got connectivity that there's going to be some way of exploiting that, and so it's really good to see in those general OT security legislations that are coming out in in all those other countries, they cover multiple industries. In Europe, it covers everything from the space industry, wastewater, clean water, electric, gas, manufacturing, and some of the big digital infrastructure. Each country has a slightly different definition of what's critical infrastructure, but we're seeing a really, really significant uptake across the world in identifying the things that are critical to civilization, a general application of a lot of controls, but all of them make reference to some sort of internal network monitoring.
Great. So, Tim, did you have anything to add to that, or?
No, I think that what they said was solid. It's there from a manufacturer's point of view, the sheer number of different frameworks that are all doing slightly different things or focusing on the same thing but different things at sometimes definitely is complicated. It would be better to see one win or one, but every country, every organization is somewhat different in their approach, and we just have to keep up.
Yeah, and that's where it wouldn't be a Dragos podcast or webinar without some mention of the SANS 5 critical controls. And not to be a broken record about it, but these are 5 very simple things that we know will deal with the majority of the adversaries that are out there. And those controls talk about putting in place a secure perimeter, having good secure remote access, good vulnerability management, risk-based vulnerability management, having an instant response plan and monitoring what's going on inside. If you do those 5 things, not only will you deal with the risk, as a consequence of that, in many cases, you'll actually be compliant with lots of different legislation. And I work with a lot of a lot of customers, a lot of utilities in particular, who operate now in a global sense. They've got assets in multiple countries. In some cases, they've got assets that span countries, and so they've got different legislation at one end of an asset to the other. And all of them have that same question. What should I do? What's the benchmark? What's the best thing? And the only thing that they've really got to latch on to are some of the big IEC standards, but they're all striving for what good will look like in the future. IEC 62443 would have you encrypt everything and multi-form authentication on every device, and it's got some good steps in there, and it is a progressive, but it's a very, very difficult thing to digest. And actually, you could rush to do all of the things in there and not mitigate the risk. And the 5 critical controls are the most pragmatic steps that I've ever seen to actually mitigating a lot of the risks that are out there. And I like the fact that different vendors have taken slightly different approaches to to actually trying to secure their products. But there's also there's that recognition of are all of those controls doing the right thing for those devices? Should we be adding multi-form authentication and user remote authentication to protection IEDs? Probably not. It's going to increase the complexity of the device. It's going to increase the number of vulnerabilities in that device that have to be dealt with. I think it was a utility shared with me the statistic, but you could add OpenSSL to an IED or relay, and it would multiply the code base by 10. And you would have a vulnerability to deal with every few weeks rather than once every few years. When some researcher has been prodding it for a long time. Focus in on the core capability of the device and think about how long it has to last and build for that. And so there's those standards, that are out there that are often driving a lot of complexity. And then you've got all these other, legislative standards that people have to follow, and and they're complicated. And thankfully, in terms of NERC CIP-15, it's not a complicated standard. It's prescriptive about where. It's prescriptive in terms of the types of what the technology needs to be able to do. It adds in place a lot of things about operationalization and governance, documentation, which are important to be able to demonstrate compliance in a heavily regulated space. But it's not striving for some technology that is not ready for the market or is not ready to be implemented yet. And it really is proportional to the risks and threats that are out there. And that's what I really like about it. It's everything that comes out from NERC CIP tends to be very long, it's been thought through for a long, long time. It's got to be approved by a lot of different parties to make sure it is really proportional and necessary. And then it gets out there and it has to be done, and that really does help organizations to know what they need to do and get something done.
So another question here, and let me paraphrase what the question is, because I think this is something that we talk about a lot, and I talk with my customers quite often about, and that's this version is the first version, and there is more. I think the general consensus is there's more to come. So what direction do you think this is going to go? Like, what things do you think are going to be added? What's your thoughts on the evolvement of 015-1?
Yeah. So I think the scope is the first thing to think about. And as I mentioned earlier, you could just focus in on the ESP at the edge of the substation. But most utilities deliberately engineer their substations, in particular those BES medium substations with externally routable connectivity. It's a very specific definition. Have been engineered to keep that number of assets very low. They've been deliberately segmented so that they haven't got routable connectivity, so that they don't have to apply a lot of the controls and instead serially connect things downstream. We already know that the technology is changing. It's going to get harder and harder to implement just serial links to maintain segmentation. There's a greater desire for more and more data from the sites. So we're seeing more assets falling into that category. But if you look at a substation that has those serial links, just because there's a serial link to it doesn't mean that there's no threat to it. People can still come into site with a transient device. Those devices are still often on a LAN that could be monitored and could have threats on it. And so if you're going to go out there and deploy a sensor just to meet the scope as it's defined today, you'll be missing out on an opportunity to get better visibility. But it's likely that those things will be there. And we saw that with the initial challenges from FERC on the scope. They felt that the scope should be greater and it shouldn't just include that ERC as it had previously been defined. The electronic security perimeter around those externally routed assets. It included things like the physical access control systems, very digital things that are part of that wider security ecosystem. If you don't look after your PAC systems, then you won't necessarily be achieving the requirements that are defined in CIP-14. And so FERC have taken a very holistic view, thinking about digital stuff in sites is obviously all important. It's all been put there for some good, positive reason, and all of it's at risk. And therefore wanted to increase the scope of that. And I think we need to consider that over time, we'll start to see greater and greater utilization of some of the things like condition monitoring systems for phasor measurement units, things that are just seen at the moment as being informative and sources of data being used for operational control. Their criticality will increase, and therefore the need to monitor them for cybersecurity threats will increase as well. So try and cover as much as you can when you go out there to be prepared for any changes. Be ahead of the legislation, just because there's a risk wherever anything is digital.
Nick, do you have any thoughts on this?
Yeah, I'll kind of expand on kind of some of the things that Phil said. When you look at a large generation facility, and I kind of mentioned this earlier, there's a lot of outlying areas. There's a lot of opportunity or places where like a wireless device can be plugged in or things like that. And I think that's kind of whether it's accidental, right? And I've actually seen this happen where someone accidentally plugged in a phone into a computer, right? That was set to tether mode and things like that. And that creates a large problem. And, not knowing about something like that, whether it's malicious or not, there's opportunity to be had. So I could see where the scope could be refined to really be wanting to look for things like that. Because, when you look at the life cycle of the persistent threats or just an accident like what I was mentioning, you're not going to necessarily catch it all the time on the inbound outbound, right? And so having that true east-west and where the activity might be happening or that foothold might be being established could be important and overlooked and missed if we're not expanding that. So I could really see that happening. And then from our customer standpoint, there's always just the concern of that scope creep on these regulations. So a lot of our customers try to stance like, well, we're going to be medium from a fleet standpoint, right? Whether we are medium or not. So I think a lot of our customers will be starting to look at this and be like, okay, well, we're going to just need to prepare for the future. And I think that's really a wise decision to be, what was low might be medium tomorrow, or what is medium today might be low tomorrow, and how it might move or transition. And I think where they're going to take a look at that and consider that with this. And I think, as mentioned, and we're kind of going to beat it up, but the value of this goes beyond just the protection. And I think that, they'll see that and bring that into the system.
Tim, from your perspective, what are the conversations are you hearing or having around the versioning of INSM moving forward?
Well, I think kind of how, and I believe the way that this questions was stated was kind of looking at how it's going to expand into lower or other organizations. I think it's going to take time to make it regulation. However, in many cases, it's already being done. And I'll give a couple examples of that. But as Phil stated earlier, enforcement of CIP-015 is going to take, it's like 3 years out. But it's important to get started now. And it's important to give utility customers time to understand what is the right fit for them. It's going to allow them to work with Dragos and other manufacturers and SEL to implement security features inherent to the systems you already own. If networks are beyond capable life, upgrading to technology like OTSDN could be more efficient in sending the traffic to the Dragos sensors. But I'm encountering that. I've already seen utilities in the US and around the world mandating like renewable energy sources, especially solar and battery energy storage systems, to add SEL OTSDN and Dragos detection before they're even allowed to connect to the grid. I've seen how proactive NRECA and municipal utilities approaching and their approach on cybersecurity. They're smaller, they're faster, sometimes they're a little bit more nimble to be able to do something than a really large utility. Um, and as more renewables add energy is being added or connected to the grid, these systems will directly impact the grid at scale. Especially the variability. It's not always windy or sunny all of the time. They lack inertia, the increase in voltage control challenges. We cannot have an adversary avoid the utility, but add stress to the grid by targeting smaller organizations with less mandates. And it really truly ends up being a system of critical control systems, all working collectively together.
Yeah, that's very very much the case. So when you look at the technology that's now being pushed down at the distribution level, something that's way outside of the scope of NERC-CIP today, we're seeing a greater and greater reliance on the things that are embedded out there in the distribution network, and we're seeing so it was very rare historically to see low voltage transformers having any kind of instrumentation on them, and it was a fuse that would pop on the line. Now we've got recloser networks, and those recloser networks have fault locators and detectors on them to allow the continuity of supply to be restored quickly, and isolate where the fault is. All of those things are digital. They're all feeding back into ADMS environments. We're seeing the role of the distribution system operator expanding. No longer is the frequency still 60 hertz, and that's how we know that the demand is equaling the supply. It's very very granular level of visibility that's required, where you've got these generation assets embedded down in the distribution networks, and the aggregated scale of those distribution networks is easily as big as some of the largest generation facilities. There's a 3 megawatt solar installation is absolutely not the same level of risk as a 1500 megawatt generation station. So they are very different in their nature, but 500 of those 3 megawatt solar installations is exactly the same, and as much closer to the consumer. And many of them have common technologies. They often have got much looser connections to things like the internet, which is often the only commercially viable way of establishing communications to these facilities. And so monitoring of at least the aggregation points for the communications to those facilities, and if not, the facilities themselves, is going to become more and more common. Monitoring recloser networks, monitoring those large distribution substations, all of those things I think we're yet to see legislation for, but it's absolutely necessary, because we're not trying to protect substations. We're trying to protect energy arriving at consumers. That's the purpose of this. It's to keep the lights on, ahead of adversarial activity. Those adversaries will just pivot from the high value single assets to the very accessible distributed assets. And so I think that's going to be the next big focus of legislation. We've already seen a lot of guidance coming out from DOE, coming out from research institutions like NREL, talking about the fact that this is an increased threat, and the regulators will listen and will follow.
Great. I think we have time for just one last one here before we wrap up. And I like this one a lot because everything we've talked about today is going to cost people money, right? So the question here is, anything we should consider as we start taking this for funding within 3-5 years? Are there any opportunities we should highlight in the process, such as early adopter incentives, insurance implications, or other things? So who wants to take that to start?
I'll take that. So there's firstly, ever since FERC put out their initial order on this around INSM, there was allowance for rebate on this expenditure. So that's it was a really positive incentive to be able to directly recover the costs associated with these works. And so it really would urge people to take a look at at the scope of the works that they can get done, given that this is maybe outside of the normal existing cybersecurity budget. And even going beyond that, as as this becomes enforceable, and that incentive will disappear, in order to bake this into the rate case, it's important to consider the capital scale of what we're talking about here. When we're talking about substation engineering, you're investing in the physical asset, essentially extending the life of that asset. It's a positive investment in the networking infrastructure in order to enable things like monitoring. But it's also going to be installing cabinets, installing cables. It needs to be accurately costed, and it needs to demonstrate good value to the ratepayer. So it's necessary because we're talking about compliance. We're not necessarily having to demonstrate the need, but it is still important to demonstrate good value to the ratepayer and make sure that it's not just loading onto consumers' bills. So I think that they're the two considerations to take right now in that sort of regulated space.
I'll kind of add in on that. I think us as the vendors and the suppliers of these technologies, we can contribute not just through influence, right, but also to highlight the value outside. And I think, Tim, you hinted on this quite a bit, that there's a lot of value to these products just outside the intrinsic protections and the realization of some other benefits. And Tim, I'll let you expand on that because I didn't want to steal your thunder, because you definitely brought this up. But we can help build that case and that story and that narrative, for our customers. And I think that's something that we can do to contribute, is say, hey, not only are you going to have to spend all this money to build this, but here's the other benefits that you can derive from doing this just beyond the simple protections. And I think that's something that we can help with.
Yeah, completely agree on that one. I was also kind of thinking that the opportunities is that all large utilities are in some phase of their next generation of what they're going to design their substation to. So immediately right now, there should be discussions with the vendors for the security features that we all supply from Emerson, security controls that are built in your product that sometimes never reach an RFP, or for SEL or others. But getting it right for your next gen substation is just going to stop the bleeding, and you're going to be able to get ahead of something. So that, I guess, get those pilots, get the demo systems, understand, talk to the vendors that you're down selecting from, and then once you select, then really get that pilot started, and then use that language into that substation, that next greenfield. It's going to be a lot easier to do this in your greenfield solutions up front than have another brownfield problem that you have to try to solve 3 to 5 years from now. So the substations that begin fit this into those ones that are being built now, and get it into your specifications and your designs, and when you bring it to your testing and the site acceptance test and the factory acceptance test, it's best to have it baked in now. I think that's a huge opportunity for utilities to take on.
Yeah, retrofitting technology is always more complex than building it in at the beginning, both from justifying the spend. Cybersecurity on a new greenfield build substation is a fraction of the capital expenditure, but retrofitting it and making changes to things that are already there are disproportionately expensive. And so, yeah, absolutely, building it in as early as possible.
Yeah, the comfort factor that you have trust in the system. You've seen it at the factory acceptance test when it was hooked up to RTDSs. You know it's going to work. You trust it. You see how it could begin helping you on the operational risk side as well as the cyber risk side. And then everybody is moving forward with that trust factor that we've been kind of alluding to before.
Gentlemen, Tim, Bill, Nick, thank you all for joining the panel today. That was a great discussion. I enjoyed it. I had a good time. And thank you to everybody listening to the webcast today. And hopefully you got a lot of good information from this. Hopefully you've maybe have some new questions, which you can still submit to us. We'd be glad to hear from you. And most importantly, thank you all for helping protect our critical infrastructure that we all so desperately depend on. So thank you for your time, and look forward to the next one.